Hi, everyone. We're continuing our third unit with section 7.1, taking a look at the law of sines and looking at oblique triangles, which are triangles with no right angles. So let's get started. Okay, so the law of sines, like as I said before, it can be used to solving oblique triangles, and oblique triangles are just another term for triangles that are non-right triangles. So far in this class, we've been working with right triangles or triangles with a right angle. But now the law of sines for this section, we're working with triangles that are oblique, or there's no right angle inside the triangle. So this formula, which we're called the law of sines, can be used when you know one side and two angles, or oops, there's a typo here, when you know two sides and one non-included angle. And a non-included angle means you have a side, but then you have another angle that's not between those two sides. So the law of sines is a formula. You have A over sine A, where the little a is a side and sine A is an angle. Remember, we use lowercase for sides and uppercase to denote angles. And that is equal to B over sine of B equals C over sine of C. You're only ever going to use like two of these at a time. Like I might just use these two or just these two, but know that the ratio of all three of them are equal. So here's an example of a non-right triangle or an oblique triangle. We always use angle A or big A for the angle, and right across your little a is directly opposite of the angle A. Same thing for the angle B is here, the side B is directly opposite. And if you have angle C here, side C is directly opposite from C. All right, so let's take a look at an example problem together. Here we have solve a triangle where A is 109 degrees, C is 37 degrees, and side C is 150. And when it says solve a triangle, it just means find all the other angles that's not given and find all the sides that are not given. Again, big case for angles, little lowercase for sides. I'm a visual learner, so I like to draw a triangle just to label it here. So we have an oblique triangle. Notice how here I'm drawing a triangle that does not have a right angle. Let's label it angle A. We have angle B, angle C, and directly across from angle A is side A. Directly across from side B, we have side little b, and then directly across angle C, we have little c. Let's label anything that's given. So we know that angle A is 109 degrees. Angle C is 37 degrees. And little c is 150. Okay, so that's all the information that are given. The easiest thing to find is angle B. We can find angle B because we know the sum of all the angles inside a triangle is equal to 180. So we know that angle B is going to be 180 minus the other two angles, 109 minus 37 degrees. And that'll give us the angle measure of B. So 180 minus 109 minus 37 is 34 degrees. Okay. Now side A, we're going to use the law of sines. And the law of sines, if you go back, it's A over sine of A. So I'll write it down first, A over sine of A. And either we're going to use B over sine of B or C over sine of C. Let's use what's given. So we know side C We also know angle C, so let's use that information to solve. So we have sine, and we also know angle A. So sine C. So A, we don't know what that is. Sine of A is 100, sine of 109 degrees. And then C is 150. And then sine of C is 37 degrees. Okay, to solve for A, we can get rid of this sine of 109 degrees by multiplying both sides by sine of 109 degrees. I'm trying to squeeze this in here. Multiplying both sides of sine 190 degrees cancels that out. So A is equal to 150 over sine of 37 degrees times sine of 109 degrees. I'll put parentheses around the angles. Okay. Make sure that when you're working in 7.2, because we are working with degrees, that your mode is set to degree mode. Let's put this in 150 over sine of 37 times sine of 109 degrees is 200, let's round to the nearest 10, 235.7. So side A is 235.7. Now we have to find B. And we're going to do it the same manner. I'll just write B here. Angle B is 180 minus 109 minus 37 degrees. I need space. Let me make some space here. Okay, to solve for B, we're going to basically do the same thing. We can use solving for B by doing sine B over sine of B and using C again, C over sine of C. So B, we don't know. Sine of B, because we know B now, remember we said B was 34 degrees. Let's actually put that in because we know it now. B is 34 degrees is equal to C, which is 150 units long. Sine of C is sine of 37 degrees. So we do it the same way. So B is equal to 150 over sine of 37 degrees times sine of 34 degrees. And that'll give us how the length of side B. So 150 over sine of 37 times sine of 34. We have that B is equal to 139.4. Oops, I switched the two. So there are our solution. We found angle B and little a, which is side A, and then little b, side B. Okay, let's take a look at number 2. Okay, number 2 it says find X, and that's all the information that are given, but we're also given this triangle with some of the information filled out. So find X, it looks like we are looking for this length right here. And so that's like the upper part of this triangle. And if I were to draw this triangle kind of like on the side here, just the upper part, this part. Okay, what we're given is this angle, 20 degrees. We're also given this angle, 101 degrees. We're also given X. And remember with the law of sines, if we go back to the law of sines, you can use this when you know one side and two angles, or two sides and one not included angle. So here we're given no sides. And remember, we have to at least know one side and two angles, excuse me. So here we're only given two angles, and I'm thinking, how can we find one of the sides that are missing? Well, we can try to find this side right here. And how we can find that is using our knowledge of right triangle trigonometry. And we can call this, let's see, what can we call this? We can call this side, let's give it a name. We'll call this side C. Okay, to find C, we just considered this right triangle here. Okay, go back to your ratio, which is SOHCAHTOA. We know that if our reference angle is 11 degrees, we have the adjacent side, and we want to know C is the hypotenuse. So think about if we write SOHCAHTOA, which trig function relates adjacent with hypotenuse. Well, adjacent and hypotenuse, that's a cosine function. So we can set this as cosine of 11 degrees. Adjacent is equal to the adjacent side, or 150, over the hypotenuse, which we're calling C. We could actually, let's call it H, because it's easier to call it, that's the hypotenuse. So this is the hypotenuse. And now we can solve for H. So to solve for H, let's multiply, because H, the variable we're trying to solve for, is in the denominator, we first have to get it out by multiplying both sides by H. We have H times cosine of 11 degrees. It's equal to 150. Now divide both sides by cosine of 11 degrees. And that'll give us what H is equal to. Okay, so we need our calculator to do that. 150 divided by cosine of 11 degrees will give us that length, the hypotenuse. And that is equal to 152.8. I'll just round to one more. Let's just keep it at 152.8. Okay, so now we know this is 152.8 units long. Okay, now we can use our law of sines. The reason why we could use the regular cosine trig function for right triangles, because this here, the triangle at the bottom was a right triangle. The triangle up at the top, the slanted triangle, is a non-right triangle. And so we first used our knowledge of right triangles to find this right here. So now we can use law of sines. So we got, let's see, 20 degrees, and we have that H is 152.8. We actually need the angle directly opposite from this angle, and that's pretty easy to find. And if we call that the third angle, that third angle C would equal to 180 minus 101 minus 20 degrees. We got 180 minus 101 minus 20. That's equal to 59 degrees. Just to keep it the same, because that's angle C, we'll call the H little c again. And so now we can find X by saying, okay, X is over the angle directly across from that is 20 degrees. So sine of 20 degrees is equal to C, which is 152.8 over the angle directly across from it, sine of 59 degrees. So to get X, we can multiply both sides by sine of 20. So we got 152.8 over sine of 59 degrees times sine of 20 degrees. Type it into the calculator. Sine of 59 times sine of 20. And we'll just round to, I didn't specify, let's round to the nearest tenths place. And so X is around 61.0. So here is 61.0. We don't have any units, but 61.0 units long. So we are combining things that we've learned from before with the formula that we learned today, the law of sines. Okay, let's practice some more. We got number 3. We have this picture here that shows us a pier with 80 degrees. That's the angle with the shore, and distance 106 feet from the pier. You have a line of sight that forms a 35-degree angle, and it looks like we want to find the length of the pier to the nearest tenth of the foot. So A is already labeled for us. Okay, so if we think about this triangle, we have to find, I'm trying to do my best to reproduce this triangle. And it's not a right triangle, it's close, but it's quite not, it's kind of slanted here, like this. And we know this is 106 feet. We know this is 35 degrees. We're trying to find this side here. And instead of giving us this angle, we are given this 82-degree angle. And so to find the inside angle, because straight angles are 180 degrees, we can say, let's say, actually label this C, this is A, this is B. We can say that angle B is equal to 180 minus 82, right? Because we take 180, which is a straight angle, subtract 82 from it. And so that'll give us, we can put that in, 98 degrees. I'm going to label this 98, and I'll do it with a different color because that was not given in the problem. Okay, so we got 98 degrees inside, but remember that we need to know this angle too. And so angle C is, we can calculate that by taking 180 minus angle A, which is 35 degrees, minus angle B, which is 98 degrees. Let's put that in. 180 minus 35 minus 98. That gives us 47 degrees. And so let's label that 47 degrees. Okay, so that's everything that we need, and we can set up the law of sines now. I see that this is little c. We got little c, so we can use c over sine of c is equal to a over sine of a. Because we got c, side c, we got angle c, we don't know a, and we got angle a. So if we set this up, c is 106 over sine of angle c, we said was 47 degrees, is equal to a, which we don't know, which we're trying to find out. And then that is over sine of a, giving us 35 degrees. Okay, now to find A, we need to get rid of this denominator, multiply both sides by sine of 35. So A is equal to 106 over sine of 47 degrees times sine of 35 degrees, which is about 106 divided by sine of 47 times sine of 35. 83 point, says round to the nearest tenth, 83.1 feet is the distance of the length of the pier. Okay, so to approach this, I would start by drawing a triangle, a figure on your paper, and then labeling as you figure out all the different pieces, and then figure out like what pieces of information do I have to set up the law of cosines and use that to figure out the missing piece. Okay, taking a look at 4, the angle of elevation of the sun is 67 degrees. Okay, that's already labeled. The telephone pole says it's tilted at 8 degrees. And it's tilted at 8 degrees here, and the shadow is 15 feet long. Okay, got that. And then determine the length of the pool to the nearest foot. Okay, so again, I'm going to draw the picture here. It's really hard to draw a triangle that's kind of similar. So it looks like it's like the pole is, okay, let me try my best to do the pole. The pole's kind of like slanted this way. Sort of like that. Okay, I did my best. So here we got 67 degrees. This is angle B. And here this is saying this is angle A, which means that 15 feet is little a because it's directly across. And this is B. So that makes this side C. And so the side that's directly across is from little c, which is what we're trying to find. Okay, so how we are going to find angle B is, you can see here, angle B is actually, if I were to draw a right triangle here, this part is the right triangle. But because this is 8 degrees, what we have to do to find angle B is subtract the 8 degrees from the right triangle, 90 degrees. If we do 90 minus 8, we get 82 degrees. So angle B is 82 degrees. That makes angle A, and I'm actually going to use a different color because that wasn't given. That makes A 180 minus the 82 minus the 67. So 180 minus 82 minus 67 is 32 degrees. And I'll just label that 32 degrees. Now we got everything we need to set this up with the law of sines. So we're looking for C, so I'll start with that little side C. We have sine of angle C, and then we're going to use little side A with sine of angle A. All right, so C is equal to, or C is over sine of 67 degrees equal to A is 15 over sine of 32 degrees. And likewise, so C, we're going to multiply sine of 67 degrees to both sides. C is equal to 15 over sine of 32 degrees times sine of 67 degrees. And that will help us solve for the length of the pool. 15 over sine of 32 times sine of 67. And it's about 26 feet. I think I made a mistake. I just noticed it here. I'm sure some of you noticed it here too. I subtracted 81 instead of 82. And so that's actually, it should be 82. Good thing I caught that. So that's actually 31 degrees. That happens. Okay, so we'll just fix it. There's a little typo. And so wherever I have 32, we're going to replace it with 31. I'm just going to copy and paste. Since I have 32, 31. And we have round to the nearest foot means round to the nearest ones place. So 26.8 rounds up to 27 feet. Okay, so number 5, which is the last problem, which is one of my favorite problems from this section. Says determine the figure. Let's actually move this up a bit to save space. Here we have a cable car that carries from passenger from point A to C here. And we need to determine B to the nearest tenth of a foot. And then also find A, which is this length right here. And then also find the height to the height of the mountain to the nearest tenth of a foot. Okay, so let's see how we can approach this. First, to find B, I'm going to focus on this triangle right here. And to do that, we need to find this angle. To find angle B, that's pretty, again, this is 67. So to find angle B, we can do 180 minus 66 degrees. So 180 minus 66. 15. And so as soon as I get that, I'm going to label this 114 degrees. All right, so that means we can also find this part. And the reason I know we need to find angle C is because we know the side that's directly across from it. So it would help if we knew the angle that's across from the 1.4 miles. So to find angle A, 80 minus 114 minus 22 degrees. 180 minus 114 minus 22. So that's these. Okay, so now we have everything we need to solve for side B. So to solve for side B, we have B over sine of angle B, which is 114 degrees, equal to side C, which is this right here, 1.4 miles, over side of angle C, which is 44 degrees. And so that becomes B. We multiply sine of 114 degrees both sides. So 1.4 times sine of 114 degrees, all divided by sine of 44 degrees. And that'll give us side B. So we have 1.4 times sine of 114. And we divide that by sine of 44. I'm just being really careful because I made the mistake earlier. And we have 1.84 miles. And it's a little annoying that it's asking us for the foot. And if I didn't read this carefully, I would not have realized that. So 1.8 miles, I know that in 1 mile, there's 5,280 feet. So just multiply whatever you got by 5,280. We get 9721.2 feet. Okay, so that's, we determined B. That was part A. Part B says find A to the nearest tenth of the foot. So this part here, and we can use the law of sines again. So we have missing A, sine of angle A, which is 22 degrees. And let's use C over sine of, or C is actually 1.4 miles. So let's use that. Of sine of 44 degrees. And we have that A is equal to 1.4 sine of 22 degrees all over sine of 44 degrees, which is equal to 1.4 sine of 22, close, and then divide by sine of 44 degrees. 0.75-ish. And of course, it says foot again, and it's a little annoying. Just multiply that by 5,280 feet to get the nearest foot. Which is around 3,986.3 feet. Okay, so that is part B. Now for C, it says find H to the nearest tenth of the, again, tenth of a foot again. So C is, if we draw A into, if we know now A is, let's label this. A is 3,986.3 feet. And so we can use our knowledge of right triangles now, going back to the basics. We're given 66 degrees and we're trying to find the opposite, but we know the hypotenuse. So if I were to draw that triangle separately here, the right triangle with H, we're trying to find H. We know this is right triangle. This is 66 degrees. And the hypotenuse, the side that we just found, is equal to 3,986.3. Okay, so what relates opposite and hypotenuse? Well, that's so the sine. So we can set that up as sine of 66 degrees is equal to H over opposite over hypotenuse, 3,986.3. So to solve for H, we can multiply both sides by 3,986.3 on both sides. So H is equal to 3,986.3 times sine of 66 degrees. Let's put that in the calculator to get an approximation. 3986.3 times sine of 66, which is about 3,641.7 feet. Okay, so there's part C. Okay, so those are the 5 problems I had wanted to share with you as you prepare to do the assignment for section 7.1. Again, feel free to contact me at any time should you have questions or concerns. All right, take care and I'll see you next time.